Today we're going to be doing a video on implicit differentiation. What implicit differentiation is, basically we would always take the derivative in respect to x, d dx, but when you're doing implicit differentiation, you're actually taking the derivative of some variable other than x. So think instead of d dx, you're going to be doing d divided by dy, or d divided by dk, or any variable. Okay? So let me give you an example where we're not only going to be taking implicit differentiation, but we're also going to be using the slope formula to find our slope formula, our slope function, our slope equation. We have here x squared y squared equal to 9. Finding y prime in order to solve our equation right here, which is y minus y1 equals mx minus x1. So we have here x squared y squared equals 9. We use the product rule. And if you had watched my other video, you know how to do the product rule. You have x squared prime y squared plus x squared y squared prime equals 9 prime. When you do this, you'll find that you'll have 2x times y squared plus x squared, and remember you're taking the derivative in respect to y, so you're having 2y times y prime when you do this, because remember again, it's in respect to y. So when you do this, you have x squared times 2y times y prime equals negative 2xy squared, and what I did was, in order to get that y prime or to get rid of these two, I kind of subtracted this part right here, and I put it over here. So, in a nutshell, I took this and put it over there. I put it on the right side of the equation, the right side of the equal sign. So now we are left with x squared times 2y times y prime equals to negative 2xy squared. So now I want y prime all by itself, that way I know what does y prime equal to. So I go ahead and divide both sides by this right here, because you know this is being multiplied by y prime. So the only way to undo multiplication is to divide. So now we have y prime is equal to negative 2xy squared divided by x squared 2y times y. There's a lot of canceling we can do here. You have a y, you have 2y here, so that can get rid. That 2 can get rid of that 2. That x can get rid of that x. You have 1y here, that gets rid of that, you gets rid of that. And you're left with negative y divided by x is what y prime is equal to. Okay, so now that we find out what y prime is equal to, again, we have our slope formula, which is this right here. That's our slope formula. We want to know what our slope is. So here, I just pushed a 1 for x. Normally, that's the original equation. I plugged 1 in for x squared, to get a point. And what I found was, when I did that, when x is 1, y is equal to positive or negative 3. So I have 2 points here. I have 1, 3, and 1, negative 3 as coordinates. So then I go back here and prove it too. So my y1 is negative 3, and my m is equal to negative 3. And that's after I plug that into my y prime. So now I have this, so now I can just go ahead and plug that in with there. And remember your x1, so you can just plug that right in there, and that's it. And then you have your slope formula. And that's how you do it with implicit differentiation. Some other small examples, say you have d dx, x plus y, put it through, and because y is not d dx, you're left with y plus y prime. So there is some confusion in there, but it still makes sense in a way. So here's what you're trying to take in respect to y, d, dy. What you're going to find is, when you take the derivative of both of those, you're left with 2x dx dy plus 2y times dy dy, or dy divided by dy, when the top of it is different than what the bottom is, you're just left with a prime. That will not turn into 1. And I know that's confusing, however, when you're doing it in respect to a different variable than what it is, it's not going to equal 1. I know normally you have it in your head that x prime is equal to 1. However, in this instance, x prime will just be x prime. So now you're left with 2x times x prime plus 2y. And here's one last example other than x and y in respect to dk, just decay. You don't have a k anywhere in there, so you cannot simplify anything other than just taking the derivative. And that is implicit differentiation.